In the last video we have seen about complex stresses, and we have seen what are the formulas to find the principal stresses and stresses on the oblique plane. Those are the formulas used, but it can also be found out using Mohr circle. Here Mohr circle is representation of magnitude of normal stress and shear stress at various planes. We can find at any plane around 360 degrees we can find normal stress and shear stress at any plane, and also we can find principal stresses too. So how to find using Mohr circle? So this is the body, and it is acting with sigma x, sigma y and shear force tau xy. These are the forces acting, stresses acting on this body. For this, now we are going to draw the Mohr circle, and consider that, let us say in this sigma x is greater than sigma y. To draw the diagram, first we need to draw a horizontal line, horizontal axis, which is sigma theta. This is sigma theta, and we need to draw a vertical line which is tau theta. The horizontal is sigma theta and vertical is tau theta. Sigma theta is normal stress on the oblique plane and tau theta is shear stress on the oblique plane. First, this is the center of both axes and it is the origin of this system. And next we need to plot a point taking sigma x. Sigma x is greater than sigma y. Let us say sigma x is somewhere here. Sigma x, which means it is on the line normal stress, and there is another point which is sigma y, which is less than sigma x. So first is sigma x. Let me write somewhere. This is sigma x, and this is sigma y. And let us say this is the point A, this is the point B, and after that it is acting with a shear stress of tau xy. So in order to write the tau, if it is acting like this, the diagram should be like this, and if it is acting in this direction, if this is the body, and if it is acting like this, the Mohr circle we should take like this. So this is the force is acting in this way, so we need to consider this. From point A and point B, draw the shear force, plot the shear force. First it will be like this, and at B it will be in this way, and we need to join these 2 points. Let us say this point is C and this point is D. So these are the shear forces, and we need to join those two ends, C and D. Let me draw it with another color. So for this is the center. Let us say this O dash is the center of the Mohr circle. And now this as center and O dash C as radius, we need to draw the circle. O dash C as radius or O dash D as radius, both will be same, right? So we need to draw the circle joining this. So this will be the circle. I'll change the color of this. So this is the Mohr circle for the given diagram. So how to find any stress in this? For example, we need to find a stress on plane some 35 degrees. For 35 degrees, we need to take a line such that this total angle will be 2 theta. So that the total angle will be 2 theta, and we need to draw a line, and from this line, let me draw it aside. For example, if you need 70 degrees angle, the angle from this blue color line should be at 140 degrees. So this is 2 theta. If you need 70 degrees, you should draw it with 140 degrees angle, and from that draw a horizontal line and vertical line. From this point, let us say this point is E, and this point has coordinates of sigma theta and tau theta. This is the coordinates of point E. So what does it mean? The x-axis distance from the origin is sigma theta, and the y-axis distance and the distance on y-axis from origin will be tau theta. So let us say this point is F. And now join these lines. If you join O and E, a line is formed, and this will be phi, which is angle of obliquity. So this is the Mohr circle diagram. Then what will be the sigma 1 and sigma 2? These are this 2 theta will be the plane of oblique plane, and what will be the sigma 1? Sigma 1 is maximum principal stress. What is maximum principal stress? When shear stress is 0, that plane has maximum principal stress or minimum principal stress. So what is the plane that has shear stress 0? One is this one. This plane has shear stress 0. So this will be this point. Let us say this point is H. This H will have sigma 1, and the other angle will be this one, because it will be 2 theta, and 2 theta will be here 180. 180 means half of the, from here to here it is 180, but this angle is 2 theta, which means the original deviation will be 90 degrees, and this point will be sigma 2, which is, let us say this point is G. So from this diagram, what do we get? OB is equal to sigma x. First we have plotted this, and next OA is equal to sigma y, and AC is equal to BD, which is equal to tau. We have plotted from these points A and B this value of shear stress, and sigma 1 will be OH, which is equal to sigma 1, and sigma 2 will be OG, which is sigma 2, and shear stress, maximum shear stress will be O dash I, which is tau max. So where will be this tau max? If you draw this vertical line, there will be a point I. This O dash I will be tau maximum, because in the circle this is the maximum point where shear stress will be maximum, and it can also be downside. This is also tau max. So O dash I will be tau max, and next is OF, which is sigma theta, and next is FE, which is tau theta. So let us see all this in this diagram. First one is OB is equal to sigma x, OB is equal to sigma x, and the next one is OA is equal to sigma y, OA, which is sigma y. First we have plotted these two, and from this AC is equal to BD is equal to tau, AC BD. So we have plotted that as tau, which is shear stress, and OH is equal to sigma 1. So OH, which is sigma 1, and next is OG is equal to sigma 2, OG, which is this will be sigma 2, and next one is OI, O dash I is tau max. This O dash I will be maximum shear stress, and OF is equal to sigma theta. We have considered at this plane 2 theta, so OF will be sigma theta, which is coordinates of this point E, and tau theta will be FE will be tau theta. So this is the Mohr circle if biaxial stresses and shear stress are acting on the body. And let us see what will be the diagram if only biaxial stresses are acting on it. So let us say the diagram is like this. This is the body, and sigma x is acting in x direction, and sigma y is acting in y direction. Both are tensile in nature. And let us say there is an oblique plane theta, and on this tau theta, sigma theta are acting due to these forces, stresses, and let us say sigma x is greater than sigma y. In order to draw the diagram, first we need to draw x-axis and y-axis. So this is sigma theta, and this is tau theta. From point O, first we need to plot the sigma x and sigma y. As sigma x is greater than sigma y, this will be point B, and this is sigma x. and there will be point A, which is sigma y. And next, from this point A and B, shear stress should be plotted. But in this diagram, there is no shear stress. So shear stress will be, the shear stress which is applied will be 0. So at this point only, the shear stress will be present. Shear stress will be 0. And we need to draw a line. So this is the line we have drawn in this. So in this diagram, the shear stress is present. So we have drawn from C to D. But in case of this, the shear stress is absent. So point C and point D will be coinciding with A and B. So the circle will be formed like this. And this is the point O dash. The circle, how does the circle forms? So this is how the circle is formed. And we, in order to find the oblique plane stresses, first we need to take an angle 2 theta and draw a line, and this will be 2 theta, and this point will be point E, which is sigma theta tau theta. This will be point F. This will be angle phi, which is angle of obliquity. And what is the tau max? Point I will be the tau max, and this point will be sigma 1, this point will be sigma 2. The circle intersecting this x-axis will be sigma 1 and sigma 2. So if we write the data of this here, first is OB, the sigma x is OB, and OA is sigma y, and next is shear stress is 0, and maximum shear stress will be O dash I, maximum shear stress, and OF will be sigma theta, and FE will be tau theta. And what is principal stress? Principal stress will be sigma x only. So OB is equal to sigma 1, which is also equal to sigma x. OA is equal to sigma 2, which is also equal to sigma y. And in this, what is the radius of Mohr circle? Radius of Mohr circle is, this one is the radius of Mohr circle. From A to B, what will be the value? So radius of Mohr circle is A to B divided by 2 gives us the radius of Mohr circle. A to B will be sigma x minus sigma y will be the A to B, divided by 2 gives us radius of Mohr circle, which is also equal to sigma 1 minus sigma 2 divided by 2, and this will be modulus. And the next one, we have seen these are the cases of tensile stress. And what if it is compressive? Let us see that, and different cases are here. So the first case is uniaxial stress, only sigma is acting in the x direction. then the diagram will be like this. This is tau and this is sigma, this is tau, and there is sigma x is equal to sigma here, so this is the point B, and there is no sigma y, so it will be here, and there is also no shear stress, so the shear stress will be also on the x axis. So the circle that is formed will be so this is how the circle looks like. The distance between O and B will be sigma, and the maximum shear stress will be, this is also equal to sigma, maximum shear stress. So this is how we can find the, for simple bodies, for simple stresses, we can find easily the tau max and other values. So if compressive load is compressive stress is acting on this body, the diagram will be, first this is tau, and this is sigma, this is tau. So what is compressive load? Minus of sigma x. Here in the x direction compressive load is acting, minus sigma x will be somewhere here, so minus sigma, and there is no stress in y direction, so this will be this point, and there is also no shear stress, and this lies on x axis, and the circle formed will be in this way. If it is compressive, it will be in this way. So the distance between this will be sigma, and the maximum shear stress will be sigma is equal to tau max. And the next one is the tensile stresses are acting on both sides, and these both are equal, sigma and sigma both are equal. So how will be the diagram? This is tau and this is sigma. So from point O we need to draw the, so we need to plot sigma x. Somewhere the sigma x will be here, and we need to plot sigma y. Sigma y is present, we need to plot sigma y. Sigma, this is also sigma, so the same point will be here. And what will be the radius? The radius will be the shear stress. There is no shear stress, so that point also will be lying here. So this is the Mohr circle. The dot is the Mohr circle if biaxial stresses of equal magnitude are acting on the body. So this is the this is the Mohr circle. The point is Mohr circle for biaxial stresses of same magnitude. And what if it is compressive and tensile? So this is tau. This is sigma. There is sigma and sigma. One is tensile, one is compressive. The first one will be sigma x. Sigma x is on, sigma x is tensile, so it will be on this side. This is B. And sigma y is compressive, which will be on negative side. This will be A. Are there any shear forces, shear stresses? There are no shear stresses acting on this body externally, so the shear stresses will be lying on this. From this we need to draw the circle. So this will be the center of Mohr circle, This is how the Mohr circle will be present for both tensile and compressive. And what will be this value? This is sigma, and this is also sigma, maximum principal stress and minimum principal stress. And this will be sigma. This is also sigma because radius is sigma, which is tau max. And the next case is pure shear. Only shear stresses are acting on the body. Then how the diagram will be? So tau sigma. First, from this point O, we need to plot the sigma x and sigma y. There is no sigma x and no sigma y, so the points will be here itself. And we need to plot the shear stress. Here shear stresses are present, so it is the value of tau. So it will be here, and this point will be C. The point B is sigma x, point A is sigma y, and point C is shear stress. And another will be on the downside, which will be D, point D. And joining these 2 points, we need to draw the circle. The center will be this O. O will be the center for Mohr circle. So this is the Mohr circle. And what will be the maximum principal stress will be sigma, and minimum principal stress will be minus sigma. And what will be the tau max? Sorry, this is not sigma. This is tau, and this is tau. This is sigma 1. This is sigma 2. And this is tau max, which is equal to tau itself. So this is how we need to draw the diagram, Mohr circle diagram, for different loadings. Sometimes this question may be asked in the gate. And the next is, we have seen the Mohr circle, and next is complex strains. And the complex strains are those on which in which the strains on the complex plane or oblique plane. So in order to write the formula for complex strains, these will be same for stresses and strains. Just to replace stress with strain. So in stresses there was sigma theta. Here it will be epsilon theta, and sigma x will be epsilon x plus epsilon y divided by 2, plus epsilon x minus epsilon y divided by 2 into cos 2 theta, plus there was tau xy in case of complex stress. Here it will be gamma xy, shear strain, sin 2 theta. Here it should be modified. In place of tau xy, gamma xy by 2 should be written in shear stress. And all will be same. Only in place of, I will write it here. Put gamma xy by 2 in tau xy. And what will be the shear strain? This is first, epsilon is normal strain. Shear strain will be gamma theta is equal to epsilon x minus epsilon y by 2 sin 2 theta minus gamma xy divided by 2 cos 2 theta. This is the if we consider any plane at an angle theta to the vertical, these are the stresses. And what will the principal strains? Sorry, these will be the strains. And what will be the principal strains? Strains on the principal plane are called principal strains. Here also same formula are applicable. Epsilon 1, epsilon 2, plus and minus changes, that's it. So epsilon x plus epsilon y divided by 2, plus or minus. Plus will be for 1, minus will be for 2, under root epsilon x minus epsilon y by 2 whole square plus gamma xy by 2. In place of tau xy, we need to put gamma xy by 2 whole square. So plus is for epsilon 1 and minus is for epsilon 2. And the next is maximum shear strain. Strain on maximum shear plane. So this will be the shear stress is equal to sigma 1 minus sigma 2 by 2. It was there like this. So in shear strain it will be gamma maximum divided by 2 is equal to epsilon 1 minus epsilon 2 divided by 2. So 2 gets cancelled and the remaining is maximum strain, shear strain will be epsilon 1 minus epsilon 2. This is in case of 2D. What will be in case of 3D? Maximum shear strain will be maximum epsilon minus minimum normal strain. Maximum normal strain minus minimum normal strain in case of 3D. And on maximum shear plane, normal strain also will be present. So normal strain on maximum shear plane. This will be, let us say, this will be epsilon 1, which is equal to epsilon 1 plus epsilon 2 divided by 2, and which is also equal to epsilon x plus epsilon y divided by 2. And what will be the radius of Mohr circle in this? Radius of Mohr circle for strains will be modulus of epsilon 1 minus epsilon 2. And the relation between principal stresses and principal strains. We have seen this relation in first unit, and the same is applicable for this principal stresses also. We have seen for normal stresses and strains, and this is between principal stresses and strains. So for 3D, it will be epsilon 1 will be sigma 1 by E minus mu into sigma 2 by E minus mu into sigma 3 by E. Same formula. Epsilon 2 will be sigma 2 by E, and we need to subtract that lateral strains, sigma 3 by E, and epsilon 3 will be sigma 3 by E minus mu into sigma 1 by E minus mu into sigma 2 by E. And same follows for 2D. 3 will not be present for 2D. For 2D, we are writing a relation between stress and a strain like this. Sigma 1 will be E into epsilon 1 plus mu into epsilon 2 divided by 1 minus mu square. And sigma 2 will be E into epsilon 2 plus mu into epsilon 1 divided by 1 minus mu square. So how did we get this? Epsilon 1 will be sigma 1 by E minus mu into sigma 2 by E, and epsilon 2 will be sigma 2 by E minus mu into sigma 1 by E in case of 2D. So by solving these two equations, we'll get sigma 1 and sigma 2 in terms of principal strains. And there is a condition like this: plane stress and plane strain condition. What is plane stress and plane strain condition? Plane stress condition is in which in z direction the stresses will be 0. The normal stress and shear stress both will be 0. So this is called as plane stress. Sigma z should be 0 and tau zx should be 0 and tau zy should be 0. This is plane stress condition. And in plane strain condition, strain, so in z direction the strains should be 0. Epsilon z should be 0, gamma zy should be 0, and gamma zx should be 0. And due to this, in plane stress, due to this tau zx, gamma zx will also be equal to 0. Gamma zx will be 0 and gamma zy will be 0. Due to the sigma z, epsilon z will not be equal to 0. Only this due to this shear stresses, gamma zx and gamma zy will be 0, and this will be due to this shear strain, tau zy will be 0 and tau zx will be 0. And the next is, these all are zeros, and the other values which are epsilon x, epsilon y, epsilon z, and the remaining are gamma xy and sigma x, sigma y, tau xy. These values may or may not be 0. May or may not be 0. It can be 0 or it cannot be 0. And the remaining values in this is, first it is sigma x, sigma y, sigma z, and other values are epsilon x, epsilon y, epsilon z is 0, and there is tau xy and gamma xy. These are also may or may not be 0. So the examples of plane stress condition is like this. For example, there is a small thickness plate is there, and this plate is subjected to sigma x, and it is subjected to sigma y also, and it is subjected to shear stress on this. So this type of board is subjected are called plane stress. And what is plane strain? For example, there is a very lengthy rod, and these are subjected to stresses sigma x, sigma y, and shear stresses also are present. This is in z direction, this is y, and this is x. Then this type of stress action is called as plane strain condition. We represent plane stresses and plane strains like this. in a matrix form we represent it in this way: sigma x, tau xy, and tau yz will be 0, and tau yx, sigma y will not be 0, and tau yz will be 0. And next is, this is tau zx, this will be tau zy, and this is sigma x, sigma y, sigma z will be 0. This is stress conditions. And what will be the strains in this? Plane stress. In plane stress condition, the strains will be epsilon x will be present, may be present, and gamma xy divided by 2, and it is 0 here, and gamma yx by 2, epsilon y may be present, and here it will be gamma yz divided by 2 will be 0, and gamma zx divided by 2 0, and gamma zy divided by 2 0, and epsilon z will be present, as this is a plane stress condition. And in case of plane strain, considering stresses, sigma x may be present, tau xy may be present, and tau xz is absent, which is 0, and tau yx may be present, sigma y may be present, but tau yz will be 0, and tau zx 0, tau zy 0, and sigma z may be present. And next is strains. Plane strain in strains. Epsilon x may be present, gamma xy by 2 may be present, and gamma xz by 2 is absent, which is 0, and gamma yx by 2 will be present, and epsilon y will be present, and here gamma yz by 2 will be 0, gamma zx will be 0, and gamma zy divided by 2 0, and epsilon z will be 0. So this is the difference between plane stress and plane strain conditions. And on this the questions may be asked. There will be a diagram given, state whether it is plane stress or plane strain condition. And there are two important points in this plane stress and plane strain condition. If a material considered has mu is equal to 0, like mu will be 0 for cork, mu will be 0. This is the condition of plane stress and plane strain. Plane stress and plane strain condition. It can be applicable only for mu. Plane stress and plane strain condition both. If there is isotropic material, then principal stresses and principal strains are in same direction. We are considering it as isotropic, so principal stresses and principal strains will be in same direction. So this is what about Mohr circle and complex stresses and strains. In the next video, we will see about shear force and bending moment diagrams. I will also attach the PDF of this lecture in the description link, and also I will attach the problems for practice on complex stresses and strains. If this video is helpful for you, please like, share and subscribe. Thank you.